Number 9 is taken from the Edexcel International A-Level Math Pure 2 from the Sample Assessment Material past paper. Solve for theta when theta is between greater or equal to 0 and less than pi. So here we are working in radians, and the equation is this one, giving your answer in terms of pi. So first, in order to solve for theta, we need to have the function either in sine form or cosine form or in tangent form. So we start working by taking this to the other side. So sine 3 theta equals square root 3 cosine 3 theta. Then we divide by cosine 3 theta both sides. We will have tangent 3 theta equals to square root 3. Therefore, the trigonometric function that we're working with is the tangent. So we find the tangent inverse of square root 3. It's equal to pi over 3. You can use your calculator to find the answer, and then we start solving by writing the equation of tangent 3 theta. Instead of square root 3, we write tangent of the angle, which is tangent pi over 3. So we can now remove the tangent, and we get 3 theta equals to pi over 3 plus the periodics, and the periodic of tangent in this case is k theta. It's k pi. And now we need to get theta alone because we want to find theta. So in order to have theta on one side, we need to divide by 3. Therefore, you divide everything on the other side by 3. You get theta equals pi over 9 plus k pi over 3. Now we start taking the terms. So if k was 0 turns, theta is pi over 9. If k was 1 turn, then you would have pi over 9 plus pi over 3, and this is going to be 4 pi over 9. If k was 2, then you would have pi over 9 plus 2 pi over 3. Adding that up is going to be 7 pi over 9. Keeping in mind that these answers should be in the interval or satisfies the interval that's given to us in the first place, which is 0 less than or equal to theta less than pi. So until now, all of these values, they satisfy the interval until we reach k equals 3 turns. When k is 3, you're going to have pi over 9 plus 3 pi over 3, which means that theta is equal to pi over 9 plus pi. And here we have the limit, our limit is less than pi. So the angle that we reached is pi and more. So this is why we don't accept it. So what are the values for theta? They are pi over 9, 4 pi over 9, and 7 pi over 9. This is for part I. In part 2I, given that 4 sine squared plus cosine x equals to 4 minus k, where k is between 0 and 3 inclusive, find cosine x in terms of k. So in order to find cosine x in terms of a, we need to change the sine x squared into cosine. So we know that the fundamental relation which says that sine x squared plus sine squared x plus cosine squared x equals to 1. Therefore, we change sine squared x into 1 minus cosine squared x, and then we expand the 4 inside, and we have a quadratic equation. Now this is a quadratic equation that you can solve, or you can change variables in order for you to have a comfortable way of solving using this variable that you chose. So you say let a be cosine x. So you have 4a squared minus a minus k equals 0. This is a quadratic equation, so you use delta or the discriminant. B squared minus 4ac, which is equal to 1 plus 16k. So a, which is the root, or in other words it's equal to cosine x, is equal to b plus or minus square root delta over 2a, which is interpreted into 1 plus square root 1 plus 16k, which is delta over 8. In part B, let us read it from the question. We have when k is 3, so they gave us a value for k. When k is 3, find the values of x in the range between 0 and 360 degrees. Now in this part we are working in degrees, we're not working in radians anymore. So if k was 3, you replace k by 3 and you find the answer for the cosine, and we get two answers for the cosine. One, it's cosine x is 1, and the other answer is that cosine x is equal to minus 6 over 8. In its simplest form, it's minus 3 over 4. So cosine x equals to 1 is our first answer. Let us find the angles that can give us this answer. We know that cosine x is equal to cosine 0, where cosine 0 equals to 1. Therefore x is equal to 0 plus 360 degrees k, or 360 degrees multiplied by the terms that we can use. The only term that we can use is k equals 0, because if we have k equal 1, it would be, the answer for the angle would be 360 degrees, and 360 degrees is not included in the interval. So we only use x equal 0 degrees where it's k equals 0. We move to the other value of cosine x. We find that cosine 138.59 degrees is equal to minus 3 over 4, and we start our work by writing by writing x is equal to the angle plus 360 turns. So when x is 0, we will get angle x to be 139 degrees. And when we have, if we take k to be 1, then we are exceeding the interval. We are finding the angle which is more than 360. We take the second choice for cosine, because cosine of angle minus alpha is equal to cosine alpha. So this is why we have to take the positive angle, and then we have to take the negative angle. So x is equal to minus 138.59 degrees plus 360 degrees k. We try the terms. When k is 0, we're going to get angle 221 after you approximate it. And if you take k to be 1, so one more term, therefore this 360 is going to be more than so this is going to be k is 1 here. So when k is 1, you will have this angle, When k is 0 you have a negative angle, therefore you don't use it's less than 0, so you don't take it. So when k is 0 it's rejected. When k is 1 this is the angle. When k is 2 it's more than 360. So this is why we only have these three values for x, which is the angle in degrees when k is equal to 3.